Hi YouTube, my name is Hubal MJ. I'm a medical doctor and a full professor of sports medicine and exercise physiology at Goethe University, Frankfurt, Germany. One thing that really motivated me to get into muscle research and made me passionate about it is its incredible plasticity. Just think about the different training stimuli and the adaptation of our muscle to those stimuli. Think about the endurance runner on the one side or the strength athlete on the other side. Different training stimuli, completely different adaptations. This tells us that our system is extremely plastic here. But today we don't want to talk about those chronic adaptations. Today we want to talk about the power of a single training session. Let's dive into it. You all know what happens when you do strenuous exercise, especially if this exercise is unaccustomed to you and if it contains lengthening, so-called eccentric contractions. 2 to 3 days after that, you will have a lot of pain within your muscles, right? Sometimes it's even so bad that you don't want to contract any of those muscles that were involved in that training session, right? Sometimes it's even that bad that you don't even want to touch them. And since there is a certain delay from the exercise to the soreness, we call it the delayed onset of muscle soreness. But here comes the trick. If you do the same exercise again after a certain amount of time, for example 2 to 3 weeks later, you will experience significantly less pain. And it's not just about the pain. There are other indirect markers of muscle damage that are reduced too following the second bout. For example, the force loss. When you do damaging exercise, eccentric contractions, there's a certain amount of force loss that can be observed after the exercise. Or muscle damage markers that can be seen in the bloodstream. For example, creatine kinase. This is an enzyme which is usually within your muscle cells and leak out of the cell if the cell or muscle fiber is damaged. This is what we call the repeated bout effect. So the repeated bout effect is somehow a protection of your muscle, that the muscle is less damaged after a second bout. For example, we asked in one study the participants to jump down from a 70 centimeter high platform, a table, and jump high as possible as they can after landing. They had to do that 100 times in a row, every 15 seconds a jump. After that, we asked them, how do you feel? And they said, well, on a scale from 0 to 10, if 10 is the most imaginable pain, then it's almost 10. They weren't even able to walk downstairs straight. They had to turn around and walk backwards. But it was not just the pain. It was also the muscle damage markers that increased significantly 8 to 24 hours after the damaging exercise. We asked the participants to do the same thing 3 weeks later and asked again for pain and checked for the muscle damage markers. And they said, well, it felt like it was an intense training session, but it was not comparable to the first bout. And the muscle damage markers that significantly increased after the first bout did not really change after the second bout. You could now say, well, they knew exactly what would happen, that this will cause a lot of pain and just didn't jump that high at the second bout, but luckily that was not the case. On average, over the 100 jumps, they even jumped 2.5 centimeters higher. So this cannot be the explaining variable here. So I think it's already fascinating that a single eccentric training is able to protect your muscles and reduce the damage that is caused by a second bout. But here comes some more interesting facts about the RBE. The one thing is the duration. So if you do your first bout, your muscles will be protected for 6 months. This is hard to explain for us, and we will come to the underlying mechanisms in a minute. But I think this is really interesting that one bout is able to protect your muscle for such a long time. And research also says that the larger the damage on the first bout, the larger the repeated bout effect, the larger the protection. However, there are also data out there saying that even less damage, for example, from low intensity eccentric contractions, are able to trigger the repeated bout effect. And I think what is even more fascinating is that the repeated bout effect, so the eccentric contractions, can be shared from one side to the other. If you work out your right arm, for example, eccentrically, you will have a certain amount of protection for the other side. That tells us that there must be some systemic mechanisms here, neural mechanisms. We will come to that in a second. So one side protects the other. There's a long period of protection, and despite a long period of or intense research on the repeated bout effect, we still have problems to explain it completely. We have an understanding that it's a complex interplay here, that there are neural factors involved, that there are mechanical factors involved, and that there are changes within your muscle cells. But like I said, it's hard to explain the RBE completely, especially the long-term effect. When we say that there is neural adaptations, so your neurological part is changed somehow, we think that there is a change in the recruitment of your muscle fibers. So if you want that your muscle is activated, you send an electrical stimulus to the muscles. And it seems that on a second bout that the body recruits more of the slow twitch muscle fibers. They are more fatigue resistant, they are less strong, and they are less susceptible to muscle damage. That may play a role and might explain some parts of the repeated bout effect. Furthermore, there are some data out there that say that on the second bout, the body recruits more motor units and that the synchronization of the motor units is improved. So this helps to distribute the mechanical stress better among more fibers recruited. Apart from those neural adaptations, there are also some cellular mechanisms. So within the muscle fibers, the contractile apparatures. One thing that is thought that occurs is a longitudinal addition of sarcomeres, so that the functional units of the muscles are more and added longitudinally. And this helps to reduce the stress placed on each of those functional units. Furthermore, we think that there's a stabilization of the electromechanical coupling. So I said we send an electrical stimulus to the muscles, from your brain to your muscles, and this is connected to the mechanical contraction of the muscle. This is what we call the electromechanical coupling. And it is damaged after eccentric contractions, but somehow the body is able to stabilize that. So the electrical mechanical coupling is stabilized. And it seems that the sarcolemma, so the membrane of the muscle fibers, gets stronger, is strengthened, and therefore less of those muscle damage markers are able to leak out of the cell. Last but not least, it seems that there are some mechanical adaptations to the non-contractile apparatus. So it seems that there's an increased mechanical muscle stiffness on the one side and an increased tendon elasticity on the other side. In combination, this reduces the mechanical stress placed on the muscle. And it seems that there is more intramuscular connective tissue built up within your muscles. So also this helps to reduce the mechanical stress. Altogether, we can say that the repeated bout effect is the prime example of muscle plasticity, and that it's not only a fascinating phenomenon, but if you know about the repeated bout effect, you can use it to strategically help athletes for competitions, to prepare them for competitions, and thereby to reduce the risk of injuries. So a very interesting phenomenon. I hope you think it's interesting as much as I do. I hope you liked this short episode. See you soon. Bye-bye.